Hey guys, we're back with the notes for 8.1. This is what you should be working on after the Unit 7 test. We've already done a ton of factoring, but it's going to be super crucial in this unit as we're taking polynomials apart and trying to identify the characteristics of them. So there's a ton of stuff that you have kind of already been exposed to. I'm going to ask you to pause the screen and copy, and we're going to kind of do one of each section copied, and then I'll just talk through it to save us some time. So if you'll pause the screen, copy what you see. Great. When you have that, I'm going to have you pause the screen, copy what you see. Great. Go to the next page. I'm going to have you pause the screen, copy what you see. Perfect. And then last one, I'm going to have you pause the screen and copy what you see. Awesome. Okay, so we're going to break this down to kind of give you a checklist for identifying ways to factor. Okay, so the first one is your first step no matter what. First step no matter what, you should always check to see if you have a GCF. So a couple things I want to talk about. When it comes to a GCF, you guys are usually really good about knowing what the number is. 15, 10, 25. What do they have in common? A 5. Perfect. But when it comes to variables, it gets a little trickier. Here's an easier strategy. If you will look through each of those and label the exponent on each variable, it is always the smallest variable of each exponent that gets used in the GCF. So I may have x to the first power, x to the third, x to the first. I can only take the smallest one out, so x to the first power. When it comes to y's, I have y squared, y to the first, y to the third. I can only take the smallest one out, so I can only take out one y. Your GCF will always be written on the outside of your leftovers, and you will divide to find what's in the leftovers. So if I look back at this one, I did 15 divided by 5 was 3. I had 1x, took 1x out. That leaves me no x's. I had y squared. I took 1y out. That leaves me only 1y. I do that for each term, and that's where my answer comes from. It is very important when you get a leftover to make sure that they have nothing else in common. If they all still had an x, then I would have missed an x. If they had a y, I would have missed a y. If they were all still even, I would have missed a bigger number. So it's important to make sure that there is nothing else in common in those leftovers. Okay, so let's go ahead and do one of these together. I'm trying to find the GCF of the second one. All right, so if I'm looking for the biggest number, there's a 1 in front here, so 1, 2, and 4. No number in common for a factor. If I look for the x's, I have a 2, and a 1 for exponents. Lowest number is what I take, so I can only take one x from everybody. For the y's, I have 2, 1, and 2. Lowest number is always what I take, so I only take one y. When I write out that, I put my GCF on the outside, x, y, and I divide to get the leftovers. So if I had 2 x's, took out 1, I have 1 left. Had 2 y's, took 1 out, have 1 left. Move to the next term. I didn't do anything with the 2. I had 2 x's, I took 1 out, had 1 y, took it out, no more y's. Didn't do anything with the minus 4. Had an x, took the x. Had y squared, took 1 y, so there's still 1 left. Important to check. He doesn't have a y, so they have that. He doesn't have an x, so they don't have that in common, and they still have no other numbers together. So that is the end of that problem. If at any point this video, I'm not going to have you write or pause and write again. You should be writing as we go, but if you need to pause, please do so. Okay? All right, second one is what happens if there are 2 terms? Well, you have 2 options. You want to check to see if you have a difference of perfect squares, or you might have a sum or a difference of perfect cubes. Notice there is no such thing. Never a sum of cubes. Sum of squares. It is impossible. You cannot ever have a sum of squares. So if you ever saw something that was like x squared plus 4, you cannot factor that. Okay, just so we're clear. All right, when it comes to difference of perfect squares, you want to make sure that every piece of that binomial can be square rooted. So I could square root 4. I can square root x squared. I have a 2 and an x in that term then. I can square root 25. I can square root y to the 4th. That gives me the 5 and the y squared. Those pieces, oops, and I totally wrote that incorrectly when I wrote it again. I'm going to move this over. If you could squeeze in a little y squared here, And again, I apologize, squeeze in a little y squared here. All we're doing is putting those two terms, one time with a plus, one time with a minus. Okay? All right, let's look at the next one. First step you're always supposed to look for is a GCF. So you cannot just jump to perfect squares or perfect cubes unless you have checked for a GCF first. Okay, so in this case, both of these have a 3 in common. So I would break it apart. 3, I'm left with a squared minus 9b squared. And now because of that, both of these can be square rooted. It is also a difference because there's a minus sign in the middle. So this is an a, this is a 3b. So when I break it apart, I keep the 3 on the outside. That's my GCF. But this time I want to do a and 3b, a and 3b, once with a plus sign, once with a minus sign. Order doesn't matter. It's not a big deal. If you were to rewrite these in different orders, minus first, plus second, it would not change the answer. Okay? All right, last one I want to go over like this. This last problem looks a little tricky, but here's what I noticed. It's a binomial in the sense that there are two main pieces here. Okay, so I have this piece and this piece. There's a subtraction sign in the middle, and both of the pieces can be square rooted because of this square right here. So this piece is technically an x plus 3, and that's an underline, not a division. This 4y squared can be broken into a 2 and a y. So if I was going to write this, I would have my 2 big parentheses. I would have an x plus 3 and a 2y, an x plus 3 and a 2y, and you don't really need the parentheses around the x plus 3. It can stand alone. And I would do it once with a plus sign, once with a minus sign. That keeps you from having to FOIL it out, combine like terms, regroup it. This would be the exact same thing. Okay? All right, let's move on to sum or difference of perfect cubes. So remember, cubes is anything to the third power. So your perfect cubes are 1 to the third power is 1, 2 to the third power is 8, 3 to the third power 27, 4 to the third power 64, 5 to the third power 125, etc. We've written these in other places. If not, you could always write them out if you need a place to just kind of find them and identify them. Okay? All right, so if I zoom in and want to talk about a couple things here. First of all, when you break these apart into cubes, your first one will always be a binomial. Binomial meaning there are only 2 terms in that parentheses. Your second factor, like your long parentheses, will be a trinomial, meaning that it will have 3 pieces. The binomial sign will always match the original. The trinomial sign will always be the opposite in the first position, and it will always be positive in the second position, because when you square something, it has to come out positive. Okay? All right, so let's look at this first one that's written out for us. If I say, what is the cube root of an 8? That makes 2. Cube root of x to the third is an x. Cube root of y to the third is a y. All right, so everything is a cube. We are going to use 2 x's and y's to write this out. So 2x and y the first time with the same matching sign in the middle of it. That's a minus. Then I'm going to take 2x squared. The 2x and the y will multiply in the middle, and the y will get squared at the end. Notice that my highlighted sign is the opposite of what was in the original question, so it's a plus this time. And then I wrote it out for you so that you could see where these are coming from. So 2x squared gives me, 2x squared gives me 4x squared, and that's because I distributed this exponent to both pieces again. 2xy just gets from removing the parentheses, and then obviously y squared is y squared, okay? All right, if it was possible to factor this part one more time, you could definitely do that if you needed to, but right now we would not. Okay. All right, let's look at the second one. So first of all, I'm checking for a GCF. 27 and 125 have nothing in common. They don't both have A's, don't have B's, don't have C's, so there's no GCF. We're going to write out what that would be cube rooted to. Okay. Cube root of 27 is a 3. Cube root of a to the 6th is an a squared. Cube root of 125 is 5. Cube root of b to the 3rd is just 1b. Cube root of c to the 15th power would be c to the 5th. And again, you're basically just dividing it by 3. All right, so when I write this out, I'm going to do once as a binomial, once as a trinomial. I'm going to do 3a squared, 5bc to the fifth. If it helps you to write it out individually like we did a second ago, we can do that. 3a squared squared. I'm going to do 3a squared, 5bc to the fifth, and I need to move this guy a little bit out. And then at the end, I will do 5bc to the fifth. A little bit more space, sorry guys, and squared. All right, remember your signs in the first binomial need to be the same. The sign in the second one, the trinomial, needs to be the opposite. And this guy at the end will always be positive. All right, so we could simplify this out. First one is going to just copy like it is. Second one, if you were doing 3a squared to the second power, that means you're squaring the 3 and squaring a squared. That's a to the fourth. The middle one, I can just remove the parentheses, but I do need to multiply this 3 and 5. So 15, a squared bc to the fifth. And for that last one, I do have to square both of those, or all three of those pieces. So 5 squared is 25. And now I have b squared and c to the 10th power. All right. Remember, I'm multiplying my exponents there when I distribute that exponent in, okay? All right, that is our final answer. If we needed to factor that further, if it was a simpler problem, obviously we could do that. Okay. All right, moving down into what happens if there are 3 terms. We have a lot of different scenarios. Let me zoom out real quick. We have a lot of different scenarios. We might have a perfect square trinomial. We might have a basic leading coefficient of 1 trinomial, or we might have a leading coefficient bigger than 1. That's what we call swing and divide. So let's go through a couple of each one. First of all, here's how you identify a perfect square trinomial. If the first and last terms can both be square rooted, and you check to make sure that the middle is double their product. So it sounds a little weird. Let's talk through that real quick. Square root of x squared is x, square root of 9 is 3. Both of those work. If I put them together, 3x, and double that, 6x, it should be the middle term. If it is, and that checks out, then I go ahead and I put, let me color this real quick, I put the original 2 pieces into a binomial, and I make sure that the signs match whatever the middle was. Okay, so counter example, you don't have to write this down, but let's say I had something like x squared plus 10x plus 9. This is still x, this is still 3, but this is not double of their product. Okay, I gave you something different. If I had made it this, I still have x, I still have 3. I see that it is still the product of 2 and 3 and x. However, my sign would have to be a negative. So this one would be written as x minus 3, quantity squared. Okay, if you want to write that down, you can. Do not have to. Let's go ahead and do the same thing on the next page. We're still talking about perfect square trinomials. So I'm at the top right here above where it changes topics. Okay. All right, think about square rooting this piece. That would give me 4x squared. Square root this piece would give me y squared. So if I put those together and I double it, so 2, 4x squared and a y squared, and I put all of that together, would it make this? Yes, but I would need to make sure that I keep the negative. All right, so if I rewrite this with a minus in the middle as a perfect square, that means I am using whatever I got from the first one, 4x squared, and whatever I got from the last one, y squared. That's how you would simplify it. Okay. All right, remember, if at any point you need to pause the screen and copy, welcome to do so. We are moving on. All right, we have talked about how to factor with a coefficient of 1, like in every unit, I feel like, since unit 4. So This should be routine for you. I do want to show you just kind of a shortcut way to maybe shorten your table. If the sign at the end is positive, then I need the signs to be the same. The middle would tell me that they're both either negative or both positive. So let me show you an example of this scenario. There we go. All right, so my ending number is 10. I know the signs need to be the same. 2 positives to make a positive or 2 negatives to make a positive. This negative tells me they're both going to be negative. So when I know the factors are 1 and 10 or 2 and 5, I know they're both negatives, both negatives. That eliminates 50% of the options that I have to consider, okay? Some people also like to write it like this as they're thinking about their factors. They say, all right, they're both the same, and in this case, they're both negative. I know this guy has to be an X and an X, and then it lets me kind of do just the table number options in my head. And in this case, -1, -10 are the ones that work, okay? If we were to be looking at this problem, let me highlight it real quick, that was up here, I noticed that the signs are different. So let's talk about what that means. If your C number, like that -12, if he's a negative, then that means the signs are different. A lot of people would set it up like this: X plus a blank, X minus a blank. And then they can choose their options. A shortcut way to know this is the larger number always matches the middle sign. So because this 4 is a negative, 6 is bigger than 2, so the 6 would have to be a negative. Sometimes that lets you kind of control your table. So for instance, if I was making a table for this one, -12, I know the signs need to be different, but I would always go, when I write them 1 and 12, the bigger number needs to be negative. 2 and 6, bigger numbers negative. 3 and 4, bigger numbers negative. That keeps you 50% of the options you don't even have to worry about. I never have to worry about -2 with a +6 because I don't need the bigger number to be positive, okay? All right, hopefully that helps you kind of save a little bit of time when you're making tables. All right, next one, what to do if you have a leading coefficient that is bigger than 1. We've done swing and divide a ton. If you have a number in front and you have already checked if there's a GCF, you can swing that front number, multiply it to make that 24 on the end, factor it like normal. In this case, the factors have the same sign and they're both positive. 4 and 6 was an easy find. But whatever I swing, I have to divide back out. And if I could kind of borrow a different color, if they simplify, that's when you get a whole number. If they don't simplify, that's when you swing it back out. A couple scenarios I want to remind you about though, you don't have to write this down, just look. If you ever ended up with something like 8 plus, or x plus, let's do 2 and x plus 4. Let's say your divide number was an 8. Even though 2 doesn't divide by 8 and 4 doesn't divide by 8, you could not write it like this, okay? This is not factors, and the reason for that is that those simplify. Even though they don't simplify to a whole number, they do simplify. That 2 over 8 simplifies to 1/4. That 4 over 8 simplifies to 1/2. So my numbers actually come out to be 4x plus 1 and 2x plus 1. You do have to simplify before you can swing back out. When I say swing it back out, all I'm saying is you cannot divide it to a whole number, okay? All right. Let's do another one of these together. I have a number in front 7, but I notice it is not a GCF. I don't have anything in common, so I swing it over. 7 times 4 is 28, so minus 16x plus 28. Here's what I'm going to do. My signs need to be the same because that 28 is positive, but they are both going to be negative because the 16 is negative. I'm going to go x and x because of the x squared. So when I'm considering my numbers for 28, the only thing I'm worried about is the negative. So -1, -28, -2, -14, -4, -7. Those are my only options. The only one that makes -16 is -2, -14. Now, the title is swing and divide. So whatever I swing, I have to divide. 7 does not simplify out of 2, so I could rewrite that in my final answer as 7x minus 2. 14 does divide by 7 into a whole number, x minus 2. Okay, that would be your final answer for that. If you need to write anything else on this, you can pause it, copy that down right now. We are going to the very, very last section. I promise I'm almost done. All right, solve by group. All right, solve by grouping is the last method. We haven't spent a lot of time with it, but it gives us another option whenever we have 4 terms. So you should already have this part copied down. Let's go ahead and look at what that means. What you're going to do is you're going to start by making sure that it's ordered in a way that they have pieces in common for the first 2 and pieces in common for the second 2. So my first 2 are both divisible by 3 and they both have an A. My second 2 are both even numbers and they both have a B. So when we do that, we're going to group them by putting parentheses around the first 2. I'm going to do that in black. Parentheses around the first 2 and parentheses around the second 2. Notice I am trapping that plus sign in there with the 8. Okay, so from there, we will pull out the GCFs that they have in common. So the first 2 guys have a 3 in common and an A. If I pull that out, I'm left with 4C plus 7D. For the second ones, they both are divisible by a positive 2. I could take that out. I can also take out, sorry about that, I can also take out a B. When I do so, I'm left with a positive 4C, and I'm left with a positive 7 with a D. Now, your goal is that these 2 things match, because if they do, then you are going to write them as one of the factors, and you're going to put the 2 GCFs together in a binomial to make the other factor. So 3A and a plus 2B. Notice there is no space and no symbol between those 2 parentheses. This is showing you that it is multiplication, that they are in fact factors. Okay? All right, I'm gonna shrink this up just a little bit so I have plenty of room to write the other ones. All right, let's go through the second one. In the second problem, I noticed that these first 2 guys had nothing in common. 3 and 35, nothing. -7 and 15, nothing. But if I was to rearrange those middle 2 terms, now these first 2 guys both have something in common. I can put them in parentheses. I can take out a 7 and an A. And that would leave me with 5C minus 1D. Okay? Now we got to see if I can find the same things in common on the back 2. So let's wrap them in parentheses. All right. I notice that I can take out a 3 from both of them. And if I do that, if I took out a positive 3, I would be left with a negative D. They actually have a B in common also. Sorry about that. 3B. If I took a 3B out, it'd be left with a negative D and a plus 5C. Now, even though these are written in different orders, it's still a positive 5C and a minus D. So if I write them together, it doesn't matter which order you go in, I'm going to put the positive first. The pieces that are in common are my second factor. The GCFs are my first factor. So 7A, and that's a plus 3B. That's what factor by grouping looks like. If you need to pause, write anything else down, we are finally done with the notes for 8.1.